So I'm going to start off and I'm going to do a bit of background on the feature store. What is a feature store? Motivation for it. I am a professor at the University in Stockholm, but I'm also CEO of a company called Logical Clocks. So I'll try and be as scholarly as possible before I put on my company hat. So I'm going to talk firstly about what is a feature store. Why do you need one? What's the motivation for the feature store? And then we've built a feature store. It's part of our platform, a data platform for AI called HopsWorks. And it's the world's first open source feature store. And then I don't know how much time I have for a demo because I have to hold the microphone at the same time. But luckily I have a touch screen laptop, so I'll be able to do something. Okay. Here we have our intrepid hero here, the data scientist. And if you've never worked in data science before, and you had a vision of what a data scientist does, apart from getting paid obscene amounts of money, they might work on great problems. They might be able to help us improve the efficiency of our wind farms, improve the efficiency of data centers. They may help contribute to humanity in a great way through the application of data-driven science. And this is a great thing to do, and you get paid great to boot. So you're like, great, this is the job for me. And you know, I worked previously with Python. I love Python and I love all the frameworks around it. I like Jupyter, I like PyTorch, I like Pandas and NumPy, of course. And I'm going to go off and get this nice new job. Now the problem with this is that our data scientist comes into this enterprise and no enterprise has a single store of truth. There's never one single data lake where you find all your data. You'll have different silos, different places you can find your data. And the data scientist come in here has been working with Python and is very good at statistics, very good at machine learning, understands how to reason about data when the data is in a good format. And you throw them in here to this data lake and they kind of go, what? You know, what am I supposed to do here? You know, how do I find features in this sea of data sources? Now, I'm not a data engineer. I haven't worked with all of these platforms before. And the people who employed them say, well, you know, I'm paying you big bucks. You know, you should be able to just pull all this data together and you know, give me some insights, build me some models, make some good predictions. So the issue here is that data scientists are not data engineers, right? We don't ask business analysts who work with Tableau or Power BI to go down and dig down and find files and different databases and join the data from Kafka to Hive and so on. We give them the data in a format with which they can work at a higher level of abstraction. They can work with Power BI and Tableau to generate nice visualizations and understand the data when it's in a good format for them. So before you know, we may have some data engineers here in the room and they may not have a full appreciation for what a feature is because we'll try and define what a feature is before we talk about what the feature store is. And a feature at a general level is it's a measurable property of a phenomena that you're observing. You as a data engineer might think, well, come on, it's the age of the customer. That's a column in the database, you know. But you might think, well, okay, well, I know that machine learning and deep learning, they also use images if they're doing image classification. So it could be a pixel, it could be a raw word if you're doing NLP, or if you're doing IoT. You know, maybe you're doing some sort of anomaly detection with IoT data, so it's going to be sensor values. And then you try and say, well, hang on, you know, features are things that we use to make predictions with. So often it's useful to have aggregates, right? So we want to know the mean of something. That's a good property with which we can make predictions. And if you're more sophisticated, you'll know that we work with things like embeddings. We might take text documents and break them up into word embeddings or sentence embeddings. We might even use you know, cluster representations, so k-means clustering and so on. And we might have graph embeddings. So we basically expect all of this data, which is our features, you can see here in the x1 to xn vector, that's going to go in and train our model. And we're going to try and drive the loss to as low as possible using you know, auto differentiation and stochastic gradient descent. And you might think this is fine for a feature, but a data scientist does a little bit more work than that. If they're working with natural language processing, NLP, they may take some raw text and they may write what we call a feature pipeline. They might take that raw text, you know, make it lowercase, remove noise, tokenize it, and then they'll get some words out of that, and then they might decide to group those by post, and then we're going to look at some different features that we get from this text document. We might get word to vec embeddings and a bunch of other features that you can see. So these features, it would be great if in any organization every group didn't re-implement this entire feature pipeline. So right now, without a feature store, you may have groups that write this as code in Python code, and maybe they publish that Python code internally, and some other group, if they're lucky, might find the code, or they might not find it, and they might rewrite the whole feature pipeline. So the idea behind the feature store is that our intrepid data scientists now can work directly against the feature store instead of this sea of data. And that means basically somebody still has to take the data from all the data sources and build these feature pipelines, the ability to take the columns or the aggregates and put them and publish them in the feature store so that they could be consumed by the data scientist. And we kind of see that as the data engineer's job, ultimately. So the work still needs to be done, but hopefully it won't be duplicated and done incorrectly. So what we need to see to get to a feature store is we need to have features as first-class entities in your data platform. And that basically means you need to be able to discover features. So if somebody else has implemented a feature pipeline, you would like to be able to look for it, find it, reuse it. We'd like the feature maybe to be access controlled. Maybe not everyone in the organization should have access to it. Features should be versioned. If you have a new version, we want to make these machine learning pipelines reproducible. If features are not versioned, that's going to be a hard thing to do. We want to govern them. They're assets that a company wants to know which ones are there and control access to them. And we do this for the reasons of reproducibility, as I mentioned already. The other thing the feature store is it's a data management layer. So if you have aggregates, if you have embeddings that you've computed, you'd like other people to be able to reuse those embeddings and aggregates, because it takes time to compute them. So if you can just reuse the ones that have been computed already, you'll go faster, you'll iterate faster as a data scientist. You may also have features that need to be computed on demand. You want to be able to do that as well. And the main overriding goal of this feature store will be to help solve the data problem so that data scientists don't have to solve that themselves. So we've been working on our own feature store called the HopsWorks feature store, and we have a bunch of properties that I've listed here on the left of the feature store. So we want features to be reusable between models and teams. We want to have jobs to backfill features, to be able to compute them, pre-compute them, and have them available when you want to generate your training data from them. We want to document our features. We want to have versions of them. We want to standardize access to these features between training and serving. And we want to be able to discover features and access control for them. So the main point here about the diagram that's showing here is that if you've invested in machine learning, you've decided as an organization machine learning is core to what we do, and you decide, well, we need a feature store to manage our machine learning assets. As you add more and more features to your feature store, the cost of doing machine learning should reduce, because features will have already been implemented. Somebody will have done that BERT pipeline already for you to compute, to transform your document into a format that can be used with BERT, for example, which is used widely in NLP these days. So the goal for any organization who wants to heavily invest in machine learning should be, let's reduce the cost of machine learning as much as possible, and the feature store should help you get there. So there's a couple of other advantages to the feature store I haven't mentioned. I mentioned BERT just a couple of seconds ago. BERT is a very popular pre-trained model that Google released for doing NLP, because you can actually use that pre-trained model and specialize it by training, adding extra layers to specialize the training of your model. So you may take emails on the left in marketing, and you want to classify your emails. You take the pre-trained model and you add some extra layers, but you still have to take the emails and convert them into features that BERT pre-trained model wants to use. And there's going to be other teams in your organization that see BERT and say, this is cool, and they'll all work on it in parallel, and you'll have different implementations, maybe compatible, maybe not, of the same BERT feature pipeline. So you don't want to do that. You want to be able to reuse any effort made by one team. The other issue that's problematic is that if you have different teams and you don't have a feature store, and one team is implementing a feature in training and another one in a deployed model that's being served, and those features have different implementations. Maybe they're different pieces of Python code, they're not necessarily going to be consistent, and that can give you correctness problems when it comes to making predictions. So there are a number of feature stores out there in production, but it's a very new field. So Logical Clocks, our company, we've released HopsWorks. It's an open source platform for data and AI, as I said, and it already has a feature store in there. There's another open source platform recently released by Gojek, a company from Indonesia based on Google Cloud data products. It's called Feast. And then there's a bunch of other feature stores by Uber. We're going to hear about Airbnb later. Twitter and Comcast have also said they have, and I know there's a bunch of other companies that haven't announced that they have one. So they're being used in practice by a lot of companies, but they haven't hit the mainstream yet. So just to kind of summarize this background and introduction to what a feature store is, what we can basically see here is that the feature store is going to act as the API between our data scientists that are going to consume features from the feature store to generate training data. And then we have our data engineers who are going to write feature pipelines that either with data scientists or by themselves and publish them in the feature store. And this is a nice separation of concerns. It enables teams to organize better, and we think it enables data science to be more productive. So I'm going to have a couple of words now about, if this slide changes for me. There we go. About our particular feature store at HopsWorks, about Logical Clocks of the company. And a little bit of background on us, because I guess not everyone knows who we are. We're based in Stockholm, Sweden, but we've built a platform called Hops. It's a data platform. It's a next generation Hadoop platform. We got like 16 times the throughput of HDFS with Spotify. About a year and a half ago, we added GPUs to Hadoop. We were the first vendor to do that. And we've recently added small files on NVMe disks in our metadata layer of the file system. So if you're doing machine learning on millions of images, you can read them in seconds instead of minutes. And then finally, we were the first company to release an open source feature store. So the platform itself is it's a data platform for AI, and it does things like batch analytics. So you can have your data in from S3, read it in. You can write pipelines in Spark, and we have a data warehouse Hive. And we also support streaming analytics, so both Flink and Spark. And then we have deep learning as a kind of core tenet of the platform. I say deep learning, we also support machine learning, of course, but with deep learning, we need to have specialized support for GPUs, of course. And it's all based around the feature store. So what we can see is that we're actually a very notebook-centric and Python-centric platform. And typically users will write their jobs in notebooks and schedule those jobs and run them. And then you tend to run feature pipelines with Airflow. So you push those notebooks together to make pipelines, and then you can run those as machine learning pipelines. So a couple more things about the platform, just to put things in context so we can understand some of the features later on. Our platform has something called project-based multi-tenancy. So what that means is that if you have users, and here we have 3 users and 5 different data sets, and a data set could be a Hive database, it could be a set of models that we want to put into production, it could be a feature store, it could be a Kafka topic, or it could be a subtree in HDFS. What a project is really just a line you draw around users and data sets. So within a given project, the data scientists who work on that can be restricted to only processing the data within that particular project. They're not able to copy the data out, not able to copy data in, not able to cross-link with data outside of the project. So we do this we implement this with certificates. So it's not like your mother or father's Hadoop. It's Hadoop with TLS certificates and a distributed metadata layer. So it's a very flexible abstraction because we can use it to basically share data, share feature stores, share models that we publish amongst teams. And if you don't need to maybe have boundaries between your groups, you can just have a company-wide project where all of the models and all of the features are available. One other point about the platform, we also support distributed deep learning. That could be distributed training, so it could be collective all reduce on TensorFlow. We're using Spark to run that, or it could be hyperparameter optimization. So the way we're doing this is we're using PySpark to manage distributed jobs. So when you run a job in HopsWorks from a notebook or from the jobs UI, it's going to be a PySpark application. So inside the executors, we're going to run TensorFlow or PyTorch, and each executor will get a GPU because we have the whole stack. So we're using our own version of Yarn to manage GPUs. So what's slightly different about this is that instead of using Docker, for example, to have immutable infrastructure, we have every project will have a conned environment, which will be replicated at all the hosts. They're looking hard for me. I don't know. I'm an illegal immigrant, I guess. It's okay. I think I'm from one of the good countries, though, not one of the other ones. Okay. So one thing that we've learned a lot heavily from experience is that if you're going to do distributed deep learning, if you're going to have these large infrastructures for machine learning, you're not going to do training on one GPU, or you don't want to do hyperparameter optimization on one GPU. And really, a distributed file system makes everything easier and possible. So everything from sharing your training data sets and your test data sets to the executors so that they can just read them to do their training or evaluation, to outputting the results or logs of your training runs, to managing the experiments that you run, to managing your TensorBoard log files, to publishing your models. So when you put all of this in a single distributed file system, it becomes very easy to manage it and to have this thing scale and make it usable for data scientists. So that's the basic way in which we're managing both training with lots of GPUs and hyperparameter optimization with lots of GPUs. And just one word on the replicated conned environment approach we're using. Each project will have its own conned environment, and we do have base environments, like for Python 3 and Python 2, and the Python 3 one would have TensorFlow and PyTorch and Matplotlib and NumPy and Pandas. But there's always people who want different libraries, and maybe 20% of the time, the users will go in to pip and they'll search for a library, or Conda, because we support both pip and Conda for searching for libraries, and they'll install it, which will basically mean that we have to create a conned environment at every host in the cluster for that particular project. But then the Python libraries for that project will just work within that project. So different people can have different versions of libraries without any interference. Now, many of you will have seen this diagram before. It's been quite widely written about it. It's about the technical debt of machine learning, and Scully at Google published it, I guess, about 2 years ago. And the point of this diagram was just to show that the training of models, which is this small box in the middle, is only a small amount of the work that you need to do as a data scientist. So what we've been talking about today is really how do we make the data scientist's job easier with a feature store. So what we see the feature store as doing is solving part of the problem. So the data validation, data collection, feature engineering part, we abstract away and we make it available to the data scientist as a feature store. And you can see a little imperfection in the artwork there. And in this case, art does, reflect life. We have imperfections in our feature store. We're trying to make it better, but it's something we're working on. The other part of the diagram is, distributed training, high parameter tuning, publishing models, workflows. We have an API for that, and we use Airflow, and that's the way in which people work with that part of the platform. So really, everything becomes programmatic. These are systems that do different things, but we're making them available through APIs. So that's putting the feature store in context. But I guess the starting point for a feature store is, well, if I want to work with a feature store, what does it involve? What are the key concepts in a feature store? And I can only talk for our feature store and what we try and make available to the programmer. The programmer basically sees features, and we talked about features already. So these features are the measurable properties. It could be a column from your database. It could be some aggregate or some embedding. But we also have an abstraction called a feature group. And the feature group is effectively a job that will compute a set of related features. So typically for us, that's a Spark job. And when you compute the feature values, you will get all those feature values within a group computed together. What we have at the top then are training data sets, because that's typically what a data scientist will do with a feature store. they'll sit down, they'll look at the feature store and say, okay, I now want to train a model using these features that I see in the feature store. And they select the features, and then they say, please create the training data set for me. Now that may sound like magic, and many of you will know and think that, well, hang on, if I pick features from different feature groups and they don't have a common key, how does that work, right? Well, we have a query planner which tries to find a common key for you. But if that common key is not obvious, then you can supply that keys yourself. So even though these are the abstractions we provide, I wouldn't say that they're leak-free. You know, there is a certain amount of leakage in that. And that's something as a community I think we're going to work around and find out what are better ways of you know, keeping these abstractions as clean as possible. But you know, if you have data related to customers and you have data related to time and you try and join them together, you need to specify how you join them. So the building blocks of this feature story, we had a discussion before this at with Toby and some others about, well, what makes up a feature store? And this is really, you know, our opinion on what our feature store has. But firstly, we have a registry. You need to be able to find features. And then you have an API. You need to be able to create features, publish them, and you need to be able to consume them. The features will have metadata, the version of them, the name, the documentation. You'll have jobs to compute your features as well. And then we store features. We store training data. So we see that as a kind of a key part of the feature store as well. So here's the API for the data scientist. If they want to read from the feature store, they go to the feature store, and you can see that we have a data frame equals feature store.get features. So this is a global namespace. You basically put in the stringified name of your feature, and here we're looking for two features, average attendance and average player age, and we get back a data frame. And with that data frame, we can now create a training data set. And we support a number of different file formats for training data sets. You can have TF records, NumPy, Petastorm, which is a new Parquet data set for, you know, if you're really working at scale. It's by Uber, and CSV and HDF5. So the data scientists will typically use the feature store this way, and now they've got training data, they can train their model the way that they would normally do with the clean training data. The data engineer who's writing feature pipelines will maybe not necessarily write their code in PySpark. We also support Scala. So, you know, at one company we're writing our feature pipelines in Scala. But basically what you can see here in this particular example is we're reading up some data frame, raw data from a file using Spark, a Parquet file. And then we're engineering that particular raw data. We're just taking the square of the values inside it. And we're calling that polynomial feature group, and we register that or insert it into the feature group. So now data scientists can go and use this polynomial underscore feature group feature in to generate training data. So technically what we're using to store features is we're using Hive. The Hive, many of you may know, is an Apache project. It's a SQL on Hadoop database. And we have metadata. We extended Hive to include feature metadata. We're using the same Metastore backend, a database called NDB, to store that. And I'll just then put our feature store in context of a pipeline that you would build in machine learning. So if you're starting out with your raw data or your event data and you're ingesting it in via Kafka, you can obviously ingest it other ways using Sqoop, and we have a REST API on our platform. And you're pre-processing your data. In our case, typically it would be Spark for computing features. Typically, that data will then flow into not just Hive databases or a file system, which is HDFS compatible, HopsFS, but we'll store a lot of this data in our feature store. And from the feature store, you can run your TensorFlow or PyTorch job. And in our case, we're embedding it inside our PySpark application to do the model training. And when you've trained a model, you need to then serve the model. And we use Kubernetes to serve models. That's where, you know, models that are not used necessarily just for batch, but the models that we're going to serve over the network. But you're not done with that, right? Because this is just a pipeline. It's not, we need to schedule the whole pipeline, and we need to monitor the pipeline. So to monitor the pipeline, we write our logs to Kafka, and then we can have Spark streaming jobs to read those logs. I'll talk a little bit more about that in the next slide. And we're using Airflow to manage the entire platform. So the interesting thing, I guess, about this is that you can write everything in Python. This is Python the whole way, from feature engineering to training to monitoring your applications, and then to even running workflows with Airflow. So I said I mentioned the model serving. So the way we support it is that our platform has a REST API. So clients can use access control to their models via a REST API. And then the requests, if they pass access control, get sent to Kubernetes. It could be, for example, TensorFlow models serving a server that's running on a Docker image there. And the response, you can then log the predictions to Kafka. Now, if you're generating a lot of traffic, you might want to log all the predictions, just a certain percentage of them. But the reason why you want to log your predictions is because the key way, the gold standard for monitoring the quality of your models that are being served in production is to link those predictions with outcomes so that you'll know what is the performance of our model, how well is it predicting, and how well that prediction performance that it has at the moment, how does that compare to when we're evaluating the model? And if there's no concept drift there, we can keep going. Otherwise, we can notify and maybe retrain or do something to kind of help improve the prediction performance of the models. So I think I don't have a huge amount of time, but I'll do a quick demo if I have just a couple of minutes, just to show you, because this is all very abstract. And let's see if we can get the screen to show this. Duplicate. Okay. Okay, I'm holding the mic at the same time. It logged me out, did it? So this is running on the far side of the world, so the Arctic. So I'm inside a project here, just to tell you where I am, and we have this thing called a feature store here. We have tours for this feature store to help you get started. And what we can see here is that we have a number of feature groups. We have training data sets that get created. We have the features, and you can search for them there. And we have jobs associated with those features for training them. I can show a quick notebook then to show you what the API looks like. So this particular example notebook is it's some housing data. You can reproduce this yourself, by the way. It's a part of the tour. But what we're doing at the beginning is we can see that we're creating a Spark data frame from houses for sale. And from that data frame, we do a little bit of feature engineering. We're computing another Spark data frame, houses sold. And we have a look at some of the features for that. And then registering that particular, or generating the features from that. Here we have some aggregates we're computing, so averages over the houses sold. And basically we can then register that with the feature store. So that basically involves this line here where we call feature store.create feature group. And the API has quite a different number of features. You can have your description of the feature. You can decide if you want to compute some statistics over it, which we show in the UI, feature correlation, histograms, and so on. And then the data scientist who wants to use that feature that's been registered can just call here feature store.get features. I'll just make this a little bit larger so we can kind of see. They can call get features, which are picking basically features that came from different jobs that are originally used to compute them, and create a training data set. And this would typically be a whole notebook, just this particular cell here. And once this notebook has run and you've got a training data set, you can then go ahead and create a model, define a training function, and then run your training job. And that's basically how you get to use it. So let's have a look. Where are we going? Okay. Okay, so it's like a very quick overview of our feature store. And jump back to the slides. So if you want to learn more about the feature store, I'll give you access to it in a couple of slides' time, our platform. But just to summarize what we've been doing, we've developed this feature store as part of our HopsWorks platform because we're really trying to make it easier for data scientists to do machine learning and easier for people to put machine learning pipelines into production. We're not done. There's obviously always work left to do. We don't have an online feature store yet. We're working on it. Some other companies do have libraries or DSLs for doing feature transformation. We're working on automated data provenance. I didn't go into that in much details, but being able to show which jobs, which data sets were used, were generated by which jobs, and which models used which input training data sets to train them is very important. And technically we also are looking at, we're using Hive, so we want to use Hoodie to do incremental updates on Hive when we backfill features. So if you want to look more at the platform, we're doing a few events in the Valley in the next 6 or 7 weeks. I guess the one of interest is we have a hands-on lab in Palo Alto on the 23rd of December. I think it starts at 5:30. These slides are available on the meetup side, so if you just click on that link or go to our website, logicalclocks.com, you'll find it in the events section. And it's limited in spaces, so get there early. You can read more. We have a blog article, quite a long blog article on Feature Store written by Kim and myself. And if you want to try out the platform, you can follow this link here, number 2, and there's a couple of instructions. We have a managed version of the platform running at hops.site, and we'll give you access to it with a bunch of GPUs to use. So that's it, and I think I'm about on time-ish.